This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at completing the square. And when we talk about completing the square, we're basically talking about the process by which we convert the standard form of the quadratic equation into its completed square form. That is ax squared plus bx plus c is then converted into the form a times x minus h squared plus k. Let's rewrite this h. So how do we convert a quadratic expression slash equation from the standard form to its completed square form? There are two methods. First is what we call equating coefficients, right? And the second method is what we call direct algebraic manipulation. So in this video, we'll be looking at the method of equating coefficients, right? And when we talk about equating coefficients, we're basically saying, hey, let's take ax squared plus bx plus c, and we're going to equate that to ax minus h in bracket squared plus k, and we're going to expand our right-hand side, right? Going to expand this right-hand side here. And then we're going to equate the coefficients from the left-hand side with the coefficients from the right-hand side. Now I know that we don't remember what are called coefficients. So here, a is the coefficient of x squared, b is the coefficient of x, and c is called our constant coefficient, okay? So on this side of the equation, once we expand a times in bracket x squared minus 2xh plus h squared, close bracket, plus k, and then we can distribute a throughout this bracket, which then gives us ax squared minus 2ahx plus ah squared plus k, which means that from this form, we can then solve for the parameters h and k by equating the coefficients, right? So if we look on our right-hand side, we see that the coefficient of x is now negative 2ah, and the coefficient of x squared is still a, and the constant term then becomes h squared plus k. So we'll be using this technique and we'll be solving for the parameters h and k. And then once we have those, we can write down the completed square form. So why is this important? This is important for two reasons, all right? The first reason this is important is that the completed square form allows us to understand the derivation of the quadratic formula, right? So let's write that down. So in order to understand the quadratic formula, we use the method of completing the square, and that's where we will derive the quadratic formula. The next reason it is important is that it helps us to understand the graph of the quadratic equation, right? What in particular? We can find out what is the minimum value or maximum, right? We can also find out the equation, right, of the line of symmetry. And we can also understand the shape of the graph, okay? Well, not necessarily linked to the completed square form, but we also want to understand that from completing the square, we can get these orientations inside of our mind. We can figure out where the minimum value is, right? We can figure out what value of y is going to be the maximum, and we can figure out the line of symmetry, okay? So let's jump right into some examples. So here we have our first example, which says we're to write the expression 2x squared minus 18x plus 10 in the form ax minus h all squared plus k, right? So we begin by saying 2x squared minus 18x plus 10 is equal to a times x minus h all squared plus k. And we expand our right-hand side much the same way that we did a while ago, right? So this then becomes a times x squared minus 2xh plus h squared in bracket plus k. Then distributing throughout, we get ax squared, right? Minus 2ahx plus ah squared plus k, right? So with that said, we can now equate the coefficients, right? So on the right-hand side, the coefficient of x squared is a, right? And that is on our right-hand side. So this is the right-hand side. This is the left-hand side. So on the left-hand side, we see that the coefficient of x squared is 2. And on the right-hand side, the coefficient of x squared is a. So therefore, if I am equating coefficients, right, based on the name of the method, we see that a is equal to 2. So we can say that we are equating coefficients of x squared, and that gives us a equal 2. Now I can say equating coefficients of x, right? And if I look on my right-hand side, I see that the coefficient of x is minus 2ah, right? And on my left-hand side, I see that the coefficient of x is minus 18. So that means I can take my minus 18 and I can say minus 18 is equal to minus 2ah. Do I have a value for a? Yes, I do. So I can transpose here for h, which gives us, this implies that minus 18 divided by negative 2a is equal to h. Thus, we know that h is now equal to minus 18 divided by negative 2 times what was the value for a? It was equal to 2. So then this is equal to minus 18 divided by minus 4, which is equal to 9 over 2, which is the same as 4.5, right? And now I shall try to find our last value, which is k. So this means we can now take the constant term on our left-hand side, which is 10, right? So we can say equating constants. So this means 10 from our left-hand side is equal to ah squared plus k on our right-hand side, which means now 10 minus ah squared is equal to k. So what is a? A is equal to 2, which means that I can now take 2 times, what was h? 4.5 squared, and that is equal to k. So that is the same as 10 minus 2 times 9 over 2 all squared equals k. So this means we have 10 minus 81 over 2, which is the same as 20 minus 81 all divided by 2, which is equal to negative 61 divided by 2. Therefore, after solving for both k and h, we can now write down the completed square form for our equation. So now I can say 2x squared minus 18x plus 10 is equal to 2 times x minus 4.5, which is my value for h, close bracket squared, minus 61 over 2. And that would be the completed square form. So it's important to recognize that here, after finding the value for h and k, we can immediately write down our completed square form. Let's look at another example, right? So here I have example 1.5 for us. This one is also a bit crazy. Let's jump right in. it is asking us to write minus 7x squared plus 2x minus 16 in the form a times x minus h all squared plus k. And this is the completed square form. So once you see a question that looks like this, it's basically asking you to complete the square. And here we're using the method of equating coefficients. And as you can see, I've listed here for you the steps which are involved. And once we can complete these 3 steps, you can complete the square for any quadratic expression. All right, so the first step here is for us to take our minus 7x squared, right? And 7x squared plus 2x minus 16, and we're equating that to a times x minus h all squared plus k. Expanding our right-hand side gives us a times x squared minus 2ahx plus ah squared plus k. And we've done this around 3 times now, so we should be familiar with that expression, right? No questions. So here, let's look at what are our coefficients. So here, the coefficient of x squared on my right-hand side is a, and on my left-hand side, we see that the coefficient of x squared is negative 7. So that means I can write down negative 7 is equal to a. So I've just solved for a, which is straightforward. Now, the next term I want to solve for is my h. And to solve for h, we have to take our coefficient of x on our left-hand side, and we equate that with our coefficient of x on our right-hand side. So this then gives us 2 is equal to minus 2ah. So transposing here gives us, and the step in the transposition is always the same, guys. So don't overcomplicate it. So this is 2 divided by minus 2a, which is equal to h. So what is my value for a? My value for a is negative 7. So here I plug in 2 divided by negative 2 times negative 7, and this gives me h equals 1 over 7, because here negative 7 times negative 2 is equal to positive 14, and 2 into 14 goes 7 times. So we found h. Next, we move on to finding k, and we find k by equating the constant terms. So here, if you look at our equation, we have negative 16 being equal to ah squared plus k. So let's write that down. We have negative 16 being equal to ah squared plus k. So this means we can solve for this by transposing. And as I said, the transposition step is always the same. So k is equal to negative 16 minus a times h squared. So let's plug in those values. So that's negative 16 minus a. What is a? Negative 7. So we have our negative 7 right here, and we're multiplying that by 1 over 7 all squared, right? Let's jump up here. This means k is equal to negative 16 minus, well, that's actually plus, because both negative times negative gives you positive. So that's plus 1 over 7, right? And if you are not seeing that, then it means your arithmetic skills are very weak. So you need to watch our video on arithmetic. We now have k being equal to negative 16 times 7 plus 1, all divided by 7, which is equal to negative 111 over 7. Right, so now that I found k, I can write down the completed square form for the given expression. So therefore, negative 7x squared plus 2x minus 16 is actually equal to negative 7 open bracket x minus h. And here, our h is a negative. So, well, our h is actually a positive. So this is x minus 1 over 7, close bracket, all squared, minus 111 over 7. So this completes our process of completing the square. So once we write down that expression, we are finished with the completed square process. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.